Here's a question that I hear a lot. What's the difference between the dinosaurs that lived on the land, in the sea, and in the air? Well, the answer is only the ones on the land were actually dinosaurs. I'm about to show you the two big rules that dinosaurs ever followed, and it's going to be awesome. In order to be a dinosaur as we think of them, you basically had to just do two things. First, you had to walk on land with your legs straight down beneath you. Second, you had to have feathers, scales, or a combination of both. We can dig deeper into some of the other rules, but that's basically it. Take a look at this. My Tyrannosaurus skeleton, for example, has both of its legs running straight down from its hips. Now sure, it's a biped, they walked on two legs anyway, so it makes sense for them to go straight down. But what about some of the four-legged animals? Here is an Ankylosaurus, with its four legs going straight down beneath the bulky armor plating. And look at this awesome Apatosaurus, rearing up with its hind legs right beneath it. Landosaurs, check. But what about the water world? This is a Tylosaurus, a type of mosasaur that we find in Kansas. Instead of legs, it's got flippers, which sprawl out to the side, perfect for an animal that swims all day. These limbs are held on by structures similar to what we see in crocodiles and alligators, monitor lizards, and other reptiles. We call these marine reptiles.
Look, up in the sky!
Oh, right. Soaring overhead during the Mesozoic period were the pterosaurs, a whole order of animals with broad wings and creative pronunciations for the letter P. The pteranodon had a wingspan of up to 18 feet, and its stylized shoulders and hip structures kept its limbs sprawled out to the side for better aerodynamics. And my little friend the Rhamphorhynchus here is another example of what we like to creatively call the flying reptiles. We're going to continue the discussion about some other amazing discoveries made in paleontology today. So, Dean, welcome back. I'm glad you're here again with us. You've done a lot of really amazing field work and a lot of incredible discoveries. But there's one particular animal, with our focus on marine fossils and marine animals now, that you've done a lot of work with ichthyosaurs. And I know you said that's how you kind of got your start. Can you tell us some more about your experience with ichthyosaurs?
I have spent the last decades trawling around museum collections, traveling the globe, looking at fossils of ichthyosaurs and thousands of specimens. But my first sort of major discovery came in my hometown museum, Doncaster Museum and Art Gallery, was this ichthyosaur misidentified as a plaster copy where it had been sort of actively used by the education department, which, you know, at the time, it's understandable. They didn't have a paleontologist. The last paleontologist died in 1912. So I identified this specimen when I was 18 as the real deal, a real specimen. And I went on to identify that as a new species, working with Professor Judy Macere from Rockport College in New York. And she and I named it in 2015 as a new species called Ichthyosaurus anningae, after the early Victorian paleontologist and my hero of science, Mary Anning.
So the ichthyosaurs, for those who aren't familiar with them yet, are massive marine reptiles that kind of bear a passing resemblance to a modern dolphin, correct?
Yeah, correct. And I mean, they did range in size and shape quite a bit. The Triassic form, so the first group, the first species that appeared roughly around 248 million years ago. Most of the early ichthyosaurs are quite small. Mm-hmm. A lot of them were sort of shaped like, if you imagine like a lizard with fins, that sort of thing, sort of small lizard-like things. And then eventually you evolved in the Jurassic, this sort of typical dolphin-shaped body or whale-shaped body to some extent. And that's your sort of popular, famous ichthyosaurs like Ichthyosaurus, Stenopterygius, and co., which are the sort of more commonly known ichthyosaurs.
What are some of the things that we look for to know this is an ichthyosaur specimen compared to something else like a mosasaur or some of the other marine reptiles or plesiosaurs that are out there?
Well, say for plesiosaurs then, so of course all plesiosaurs, even the short-necked ones, the pliosaurs, they still have comparatively longer necks. They're very, very different in morphology to ichthyosaurs. You know, your ichthyosaur standard body shape is essentially, you've got a really big eye at the back of the skull. The back of the skull is basically all eye, and then you've got a snout full, often of either sort of needle-like teeth or robust teeth, depending on which species of ichthyosaur. So the dentition is one really good way of identifying it as an ichthyosaur versus, say, plesiosaur and mosasaur or whatever, which is a subject we're going to get onto very shortly, right?
We're going to get to that in one quick second. Let's go back to the pregnant ichthyosaur. So you've actually found these ichthyosaurs. So marine animals, I know there are some types of marine animals that lay eggs. Sharks have egg casings in some cases, and then fish have all different kinds of eggs. Did ichthyosaurs, were they egg-laying creatures or were they live birth creatures?
Yeah, see, you would expect, and it was for a very long time thought that given that ichthyosaurs are reptiles, reptiles characteristically lay eggs, that ichthyosaurs must have come on shore, and laid eggs. But the weird thing is their bodies are so adapted to a marine environment, and they have these excellent forefins, again, adapted to help with sort of braking and maneuvering while swimming, that they don't have the sort of physiology, the capabilities to come on land. It didn't make sense. And so way back in the, early 1800s, there were some really interesting discoveries found in Germany, a bunch of quarries around a town here called Holzmarden. And inside the rib cages were sort of tiny bones of other ichthyosaurs. In some respects, they're even complete specimens, tiny, small ichthyosaurs inside the rib cages of adults. And at first, as you can understand, they were all assumed to be stomach contents, that these ichthyosaurs were cannibalistic. But as more and more and more specimens were found, and now at Holzmarden, there's well over 100 different specimens there that are being found with the remains of tiny ichthyosaurs, some of which include over 10 individual babies. It's clear that they're not cannibals and that they're actually pregnant. As I mentioned, they've been found up to having like over 10 individual embryos inside. So it shows that there's clearly differences among. Yeah, that's amazing, isn't it? So it shows there's differences among species of ichthyosaur in terms of how many babies they carry. So that is just such a cool thing, isn't it, to find? It's one of those questions you don't anticipate being able to answer, because how would you know?
You have to know to ask that question first. It's so interesting to see how, when you look at the roles that different animals have in the environment now, like the ecological niches that each creature performs, those that are the composers and the decomposers and all these different roles that they take on, we see those same jobs that exist today still happen back then. And so that's a major part of what modern paleontology is. It's not just about how big are the bones and where do you find them and use some dynamite to blast them out of the mountainside. It's about seeing how all these creatures interacted with each other in their environment. And so I know we were talking a little bit while before that in one particular discovery that you've recently made has shifted that entire paradigm, the whole idea of how these animals interact with each other. And what is the largest animal that ever lived?
Okay, so we're going to get into this one.
Let's do it.
So for a very long time, it's been thought that the biggest animal that ever lived is the blue whale, which is an enormous animal. It's still alive, which is obviously amazing. You can go out potentially and see the biggest animal that ever lived. It's up to, I think the biggest on record was something like 31 meters in length, which is truly enormous. That's like the length of 3 buses, right?
Right.
So it's a gigantic animal. And the sort of rival to that is sauropods, the big sauropod dinosaurs. So I think the biggest estimates for sauropods, you're looking again about 30, 35, maybe up to like 40 meters. So
that's going to be like the Argentinosaurus and the Sauroposeidon, and these massive titanosaurs. Yeah, absolutely.
Yeah, exactly. I mean, these are the biggest animals ever to walk on the earth. They're incredible. But most of the big boys are known from bits. And so obviously when the estimates come in, and I guess probably the best estimate to say for some of these big ones is about 35 meters, I think, for Argentinosaurus. But again, most of it is based on fragments.
To add a little extra value to what Dean's talking about, let's meet some of the other deadliest creatures on Earth. The Tyrannosaurus Rex wasn't the world's largest carnivore, but at 45 feet long, she's a pretty good place to start. We just met the Shonisaurus, a 14.9 meter long ichthyosaur, a marine reptile. Other marine reptiles, like the Tylosaurus, the world's largest known mosasaur, tops out at about 46 feet. The world's deadliest ancient shark, also known as the megalodon, is about 50 feet long, 15.2 meters. Let's make some room now for the rest, shall we? The Argentinosaurus is by no means complete, but we estimate it to be about 98 feet long, almost 30 meters. The blue whale, the largest known living animal, is 79 feet long, a 30-meter-long creature. Now, if Dean's calculations are correct, this new ichthyosaur may top the scales at over 35.9 meters long, becoming the largest creature that ever lived.
Well, a study of mine published just this year, which is actually open access, so anybody can go and read my research and look at the images in there, was based on a discovery made a couple of years ago by a friend of mine who's a great fossil collector called Paul de la Salle. And Paul contacted me, and he sent me an email, me and my colleague, Professor Judy Macere. He sent us this email saying, oh, I think I found something. And I was like, oh man, that looks pretty impressive. It looks like a part of a jaw from an ichthyosaur, but this is huge. He had a scale bar in there, and this was bigger. You know, here's your 10 centimeter scale bar, and this thing was like that. So this was just a chunk.
Wow.
And I asked, have you found more of it? And he said, yeah, I've got 4 other pieces. And all these 4 pieces fit together. I instantly said, look, I need to come and see this specimen. So I arranged to go and see this specimen with Paul. He took it to a museum in Bristol Museum and Art Gallery, where we looked at the specimen. And I just happened to have with me right here a 3D printed cast of the specimen, which is that big, it doesn't even fit on the screen. This is it. It is enormous. Let me turn it around just a little bit.
Oh my God.
There's the front of the bone.
Yeah.
This is basically all of the 5 pieces put together. So there you go. This is the back end. And I'll have to go a bit further back. There we go. Is that almost fitting in there?
That's not even close. We need to go to 4K to get all that to fit in there.
There you go. But there's a whole bunch of like telltale signs on this specimen that it is from an ichthyosaur. So it's really difficult to make out in here, but there is a sort of groove in here,
right?
Which is typically found on a bone called the serrangula in ichthyosaurs.
Where is the serrangula? Where on the body is that?
Oh yeah. So that's in the lower jaw, so in the mandible of the ichthyosaur, and it would have sat right at the back of the lower jaw. But you can see on this side there's this big groove running through here. So there you go. So there's a groove right here which runs right through, and that's a really telltale sign that this bone is a serrangula. That groove is called a foramen, and on this side, which is the medial side, so it's towards the center of the.
So this is the inside of the jaw.
That's it. That's the inside portion of this bone. It's a telltale sign that this is 100% a serrangula, and all of the shape and all the features indicate that it's from an ichthyosaur. Now, this entire bone is just less than 1 meter, and it's incomplete. And of course, bear in mind, this is only one part that makes up the skull of an ichthyosaur. So chances are the skull of this animal was probably 3 to 5 meters. And comparing this with the previous record holder, a giant ichthyosaur found in British Columbia in Canada, is called Dinosaurus tucaniensis. The same bone in that animal, which has a total length of 21 meters, this same bone, our specimen here is 25% larger, which may indicate that this specimen was 25% larger overall. So we estimate that this animal was possibly up to 26 meters long. Now that's, of course, still, that's huge. That's the biggest ichthyosaur on record, right here. But what we've got to consider is, let me carefully pop this back down, but what we've got to consider...
Yeah, just throw it anywhere, it's fine.
just chuck it away, right? So the important thing with this is not only was it a really cool discovery, and it's definitely an ichthyosaur. I remember when I was doing the book Dinosaurs, the British Isles, I remember looking through the collections at Bristol Museum, and I came across several chunks of bone in there, which I'd read about before. They'd been published for, well over 150 years. And it so turns out that these bones have been identified as sort of dinosaur bones, probably a limb bone, so a humerus bone or a femur bone. And they were collected in Gloucestershire in the UK. They're Triassic age, about 205 million years old. These bones are actually also portions of giant ichthyosaur jaw bones. But some of them are even bigger than this thing. And one of them, again, is probably, figure this out, it's about 30% the size of this, the height of it. And so this animal, again, potentially so difficult when you're dealing with fragments, I'm sure you understand.
Right.
But potentially that would be the biggest animal ever. And the biggest estimate we have for that is over 40 meters in length. Of course, you know, we are dealing with fragments, and it's such a big, bold claim to make. Oh, I found the biggest thing. And, you know, a lot of people want to say, oh, you know, I found the biggest animal ever. Of
Sure.
course you want to do that. But, you know, we're good scientists. And so we base it on facts and figures there. And so comparing it simply by scaling is, you know, the estimate could well be that it's over 40 meters or something, which would be truly a gigantic find. And I think the cool thing with it is not necessarily just that it's possibly the biggest animal ever, but the fact that it's kind of worked out this mystery, which has been around for over 150 years, of these so-called dinosaur bones from the Triassic of the UK, and they're actually giant ichthyosaur bones. So that was a lot of fun doing that. And as I say, you can read my research about this published in Plus One.
And we're going to have a link to that research right here below this video. So anyone watching this at any time, you can just click right below and we'll share that so you can take a look at all that sort of stuff.
Yeah, thanks for that, Jimmy. No, that's really kind of you. Yeah, I've got a whole bunch of sort of different projects on at the moment. There's a couple of books that I'm working on, which I can't say too much about right now, but that's really, really exciting and keep me super busy. But I guess in terms of my research, I'm currently working on a really large skull, nowhere near as big as this thing, but a really large skull from the Jurassic. It's about 200 million years old. It's three-dimensionally preserved, and it's really rare to find a three-dimensional skull from where this is from. It's from the UK. And so what we have done, we've micro CT scanned some of the bones, and working with a colleague of mine, she's helped to sort of build a three-dimensional skull. So we're getting to grips with the sort of internal anatomy of the skull of this ichthyosaur. So it's a really neat project, and it's also the biggest of that particular species of ichthyosaur. So again, that's naturally. I guess I don't work with small things, right?
No more silver medals for you, man. That's it.
This is the thing. These are sorts of discoveries that continue to ignite my interest in paleontology. You know.
Well, thank you so much for sharing all that. I can't wait to see more of the discoveries that you have coming up, and we'll be following you on Twitter at Dean R. Lomax. And on Instagram as well, yeah?
Yeah, that's what I've been doing actually. The past week I was in Germany, so I was on a little bit of a research trip looking at a whole bunch of cool fossils. So I've been tweeting about them, posting a few things. I think I did put something on Instagram. But
Dean Lomax, thank you very much again, my friend. We'll see you again soon, okay? Hey everybody, thanks for watching. I really hope you enjoyed this week's episode as much as I enjoyed making it. But let's keep the conversation going. Follow @Dinosaur Podcast on the social media of your choice. Or use the hashtag Dwaba to stay connected. Click the button right over here to become a subscriber and get notified when new episodes are available. And remember, no matter where you're from, what you do, or how old you are, dinosaurs will always be awesome.